Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 886 possible bipartition. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking that you will be given n people, and people are counted like 1, 2 and 3, so on, not like 0, 1, 2. So that should be kept in mind. You will understand afterward. Next thing is you will be given a dislike where you will be given pairs AI comma BI. Let me write it for you quickly. So what these pair signifies is that 1 doesn't like 2. Plain and simple. Similarly, 1 doesn't like 3. 2 doesn't like 4. So what is the use of this dislike? Wait a minute. Now what else? What we have to do in this problem is divide these n people into two groups so that people that don't like each other are not in the same group. That's what we have to do. What we have to do, divide these n people among two groups in which the people that don't like each other are not in the same group. That's it. That's pretty much the whole question. Only thing that you have to return is, can you do that? What is that? This. Can you divide those n people into two groups? Return true or false. That's it. That's the problem. That's everything given in this problem, and that's basically what we are doing. Now let's see. Now let's see how we are going to achieve that. How we are going to achieve that. So let's take this example and let me show you. Then I will make the intuition more clear. So 1 doesn't like 2. 1 doesn't like 3. And 2 doesn't like 4. So for example, there are two groups 0 and 1. Let 3 be in the 0 group. Okay. And since 1 doesn't like 3, it should be group 1, 2, 1. And since 1 doesn't like 2 and 2 doesn't like 1, these are both ways. They don't like each other, not one way, both ways. So if 1 is in the group 1, so 2 has to go in the group 0 because they don't like each other. And if 2 is in the 0th group, 1 has to go in the 1th group. That's pretty much it. And you can see, are we able to divide these n people into two groups? Here n is 4 people into two groups. You can see 1 and 4 is in the one group, and 2 and 3 is in the another group. 2 and 3 belongs to over here 0th group and 1th group. We were able to do it. That's what we are doing. We just return true. Now let's see. Problem is almost solved. Even I would suggest after seeing this diagram, and if you have done enough LeetCode, you can do it now. Now let's begin our our endeavor to make the intuition for this problem. So let's see. Is it looking like a graph? Yeah, you can travel both ways over here. Undirected, particularly undirected, I would say undirected. Yeah, it is looking like that. And also we are making two groups like 0 and 1. Can we say we are coloring the graph in two colors? Can we say that? Yeah, we can say that. So now problem can be stated like that. Can we color this graph, this undirected using two colors? Now problem boils down to this. Can we, let me have another pen. Can we color this graph, undirected one, using two colors? That's the whole problem now. So let's see the algo, then we will see the code, then the dry run, and then implement on your own. So let's see algo. How are we gonna do that? Do the above thing, this very basic thing. Make adjacency list. Why? Because they are not mapped in graphical fashion that it is easy to access and manipulate. So very first thing is make adjacency list. Second one is traverse this graph. Why we are traversing? Let me make this graph for you. Two, and here it is 3 and 4, and I am taking assumption that by this it is undirected. I'm taking assumption, and I already told it now, so no assumption. So this is undirected. We made this using this adjacency list. I hope this much is clear. It is pre-assumed that you know how to make adjacency list. Now let's move to traverse this graph. Why we are traversing it? If you don't traverse it, how are you gonna do it? Something over this graph. So you have to traverse it. This is what always it is in tree or graph. You have to traverse it. So which traversal? There are two traversal, BFS, DFS, BFS. You can do this problem with both, but I coded BFS. You can do DFS as a homework. That's pretty much it. There is no catch in the DFS and BFS. Plain simple DFS and BFS. How you do it regularly in the graph. I am pre-assuming that you know how to do BFS and DFS over the graph using this adjacency list. This much is clear. Now, what else we will be doing? Now let's see the main part. The main algo is that we will color the nodes. one by one and mark them visited. Because why we are marking visited? Very basic kind of thing. If you don't mark it visited, you keep on getting over same, because it is not directed, it is undirected. You just keep on doing that for infinite. You go over here, then go here. So that is clear. We will be doing this coloring and making them visited. So there are two cases if they are not visited. So what we do? Color current node with which color? Whatever color parent had, because we have to have different color. So over here we colored 0. So what we will color? 1 is 1, opposite of 0. That is pretty much clear. And also mark visited. This much is done. Else, not else, if it is visited. If it is visited, what it means? If it is visited, what it means? That it is colored. Why I'm saying that? Because we are doing, when we visit, we color it. So it is by default, whenever we visit, node will be colored. This is what we are doing. It is uniform everywhere. No rule is changed. So if it is visited, then it is colored. And what is the condition that we are looking? What is the condition that we are looking? If they have both, if they both have same color. If they both have same color. Because if they have same color, what it means? What it means? Cannot be divided. Because you know, if they have same colored, they cannot be divided. For example, 1 is colored 1 and 1 doesn't like 2, and after some computation, when you visited 2, you colored 2 a 1. But you can see that it is already colored when you go to 1. When you go to 1, from 2 to 1, and you will see it is already colored. Now it is visited. Before checking color, what we will check? If it is visited, and if it is visited, what we will check? If it is colored, and which color it is having, which will, if both have same color, then we are not able to make this graph painted in 2 colors or colored in 2 colors. That is pretty much it. I over explained it, sorry. So what we will check is color of parent is equals to color of node, and if it is, then just return false. Nothing can be done, we cannot do it, and that's it. And if fourth step, if we able to pass all these things, if we traverse everyone, what we should return is that we have successfully completed it. Now return true, because we can paint it. So that's it. That's what we are doing. This is the whole algo, the whole intuition. I hope this much is clear. Now let's see the code. Code is easy. It is pre-assumed that you need to know that BFS and DFS over the graph. Not gonna explain it. it will just make this video a long one, so I hope you understand. So adjacency list, that's how you define adjacency list. Array of vector yn plus 1, because we are counting from 1 and we are filling the adjacency list over here because it's unique undirected both sides, so that's why we are doing like this. Visited, because why not visited, because you can visit again and again because it is undirected. And this is color, because we have to color it. How are you gonna decide? You have to have some data structure in order to store that this is colored with something. That is pretty much clear. And this is what we are doing, because there can be different components, and we have to see if those components can be colored in different color, because graph can have components. This much is clear. And what we are doing, if it is not visited, then only do the BFS, else it doesn't matter, because why to do the thing that you have already computed it. So we make a BFS call, and if any BFS call tends to false, we just return the false. That's it. And if we are able to do it for every people in the group, if we are able to divide everyone, just return true. And now let's see what we are doing over in the BFS. It has a return type of bool. Here we are getting the current node, the color vector, already discussed, the visited, the adjacency list, marking it visited, making the queue, because we are using the BFS, so pretty much standard. And coloring the node with 0. We start from 0, you can start from 1, whatever you like. Basic BFS, why I'm saying again and again BFS, taking the node, popping it and exploring its neighbor and checking if it is not visited. If it is not visited, mark it visited, color that node opposite to the color of the parent. Parent is node and children or current node is adjacent node. You can see over here, basic thing, and pushing this adjacent or children or current node in the queue. And if it is already visited, what do? We check if they have same color, and if they have same color, then sorry, we cannot paint or color the graph in 2 colors, just return the false. And by the grace of God, if we did survive this, just return true. I hope this much is clear. And let's dry run this BFS and then below code. Yeah, just wait a second, bear with me. This is the main thing. Now let's see this also. After this much explanation, I hope you had made your intuition, and I'm just taking the last bit of step to make it concrete. So let's see. Let's have the test case over which we will be dry running it. So here it is, the test case. I hope it is visible. So over here we are just making adjacency list, not gonna do it one by one. You should do that on your own. So adjacency list would be looking like that. 1 points to 2. Let me write it. 1, 2, 3, 4. 1 points to 2. Similarly, 2 points to 1. 1 points to 3. Similarly, 3 points to 1. And 2 points to 4. And similarly, 4 points to 2. This is how the adjacency list will be looking, and we will be doing iteration for every people. And this is basic stuff. Let's discuss this BFS now. What is over here? We are starting from where? We are starting from 0, but I should have started from 1, because it is named from 1. Yeah, my bad. Here will be 1 and equal to n, like this. So there was no harm in it, but still. Let's see what we are doing. This is 1. We are having 1. This is color. This is visited. This is adjacency list. Already told you about it. Let's have a visited vector. Visited 1, 2, 3, 4, 0. It will be starting from 0, but 1 is visited. 1 is visited. Here we see the color. Color is also 1, 2, 3, 4. And let's see. This is the queue. This is the queue. 1 is pushed. 1 is pushed. It is marked visited. And what we do? Color is 0. We marked it 0. And what we do? We explore its adjacent after popping it. Popped it. Explore its adjacent. We explore 2. So 2 is marked visited, as you can see, marked visited. You can see given a different color. Previously it was 0, now it's 1. And again it is pushed. 2 is pushed. Now it's time for 3. Similar thing happens, mark visited. And what we do? Mark it with different color. With 1. As you can see, node is still 1 over here, because we are exploring. This is node, this is its neighbor, so that's what we are doing. 3 is also pushed. And after that, again for 2 we will take 2 out of the node and we will check its neighbor. Neighbor is 1. It's already visited. As you can see, I had a check over here for visited, already visited, but you can see 4 is not visited. So what we do? 2 has a color 1, so we did change the color and mark it visited. 4 is over here. Oh, everyone is iterated. Now it's time for 3. 3 is popped. 3, we are at over 3. 1 already visited. We cannot do anything else. Pop 4. We are at 4. We iterate its adjacent. 2 is already visited. Nothing will be done. And after that, we did survive all of it. So what we are returning? True. We did return true. And you can see over here, it ran for 1. But when you do it for 2, it is already visited. For 3, it is already visited. For 4, it is already visited. And after that, you just return true. I hope this much is clear. Let's submit it and see if it is submitting or not, because I had changed it. I didn't noticed it previously. So this is submitting, accepting, sorry. So I hope I was able to make my intuition pretty much clear, and if I was, so consider subscribing to the channel, liking this video and sharing with others. And if you have any doubt, do comment it down, or if you have any suggestion for me, do comment it down, or whatever you feel, do comment it down. So in the end, you have to do what you have to do. So keep grinding. You guys are awesome. See you in the next one. Bye bye. And please consider subscribing, because this content, if added value to it, so consider subscribing. Not value to it, value to you. So consider subscribing it. See you in the next one. Bye bye.